everyone, so today we're going to talk about inverse trig functions. Now, we're going to start off by just reviewing how the graph of a sine function and a cosine function look like. And just to review that any time that we want to figure out whether or not its inverse is a function needs to pass not the vertical line test, but the horizontal line test. And instead of looking at our entire domain, we actually sort of need to be restricted to just one part of our function. Now, with our sine graph, we're actually going to be restricted from negative pi over 2 to positive pi over 2. And again, it's because if you go past that certain point, you actually would fail your horizontal line test. And then for cosine, we're going to be in between 0 and pi. So if you go past further, you would again fail the horizontal line test. So the inverse of our sine function or our cosine function is going to be written as arcsin or sine to the little -1. So it could be sine inverse, right? Arcsine. So those are the two ways that you'd be able to see the notation. Okay, so if we went ahead and graphed the inverse trig function, we want to remember that the x and the y points, they are switched. So when we switch them, the domain now becomes the range and the range becomes the domain. So then for arcsine, you're going to go ahead and notice that the range is sort of restricting you to quadrants 1 and 4. And then for our cosine, that range is restricting you from quadrants 1 and 2. So let's just go ahead and practice how we're going to go ahead and rewrite each of our trig functions here. So now we're going to look at remembering that if you start with a cosine, we would say that we're doing our arccosine. So the arccosine of root 3 over 2 is going to equal pi over 6. And then if we wanted to rewrite sine, we would write arcsine of -1/2 is going to equal negative pi over 6. And then if we work backwards, if we're given arcsine, we would say that the sine of pi over 2 is equal to 1. And then if you're given arccosine, we're going to say that the cosine of pi over 3 is equal to 1/2. So the answers for C and D, you could verify with your unit circle. So the first thing that we want to do is go ahead and look and see what is our inverse trig function. So we have arccosine. So you want to think about the range. So for arccosine, that range is 0 to pi. So then we want to ask ourselves, okay, so the cosine of something, which we're going to say is theta, is going to equal root 2 over 2. So within quadrants 1 or 2, I want to figure out, because I know cosine is x, I want to figure out where is my x value going to be a positive root 2 over 2. So I know that would have to be in quadrant number 1. And so that answer would be pi over 4. Okay, for letter B, we have the inverse sine. So again, we want to look and see what's that range. So for sine, we're going to be between negative pi over 2 to positive pi over 2. So in quadrants 1 and 4. And then we're going to go ahead and see, all right, the sine of something, some angle, has to get me negative root 3 over 2. So then I ask myself, okay, I know that sine is my y. So where is my sine going to have that value of root 3 over 2? Well, if I think about my unit circle, again, I'm going to be in quadrant number 4. And normally what you would say is, oh, I know that angle on my unit circle. And you might say that it's 5 pi over 3. So you need to remember that 5 pi over 3 does not fit between negative pi over 2 to positive pi over 2. So you want to think about what is that corresponding angle. So you can also think about like what's that coterminal angle of 5 pi over 3. And we know that because we'd have to go in the negative direction, I can think about that being negative pi over 3. That would be the same spot as my initial angle that I thought it would be, which was 5 pi over 3. Okay, so for letter C, again, we have arcsine. So with arcsine, we're going to be in quadrants 1 or 4. So I'm thinking about the sine of something, some angle, has to get me 1 over 2. So I know my sine is my y value. So where is my y value going to be? A positive 1/2. And I know that I'm over here. And again, reminder, this is negative pi over 2 to positive pi over 2. So that is going to be negative pi over 6. So in letter D, I'm looking at inverse cosine, and I'm looking between my range of 0 and pi. So I'm asking myself, all right, the cosine of something, some angle, is going to be negative root 3 over 2. So what is that x value? So I'm looking at cosine, and I'm thinking, okay, well, I know that I would have to be in quadrant number 2, and that particular angle that I've got is 5 pi over 6. Okay, so in letter E, I've got arccosine. So again, I'm between 0 and pi. So I have to ask myself, the cosine of some angle is going to be negative 1. So cosine is my x. So where is my x going to be a negative 1? It's going to be right here. And that is going to be at pi. In letter F, here we go, arcsine between negative pi over 2 and positive pi over 2. So I ask myself, okay, the sine of some angle is going to be negative 1/2. So that sine is the y value, which would be down here. Again, you would normally think that it would be 3 pi over 2 based on your unit circle, but you have to think about the restriction, which you're given with your range. So I know that because I can go in the negative direction to figure out what that angle would be, that's going to be negative pi over 2. Okay, in question number 3, we want you to think about drawing a right triangle. So we want you to think each part at a time. So if you look at arcsine, that is 3 over 5, think about where you would draw your triangle. I know arcsine is going to be in 1 and 4. So then I think about, okay, well, the sine of something, has to get me 3 over 2. So my sine, which I know is my y value, I know is positive. So that's going to bring me to make my triangle in quadrant number 1. So again, if I just draw my triangle here, my right triangle, there's my theta. So sine is going to be opposite over hypotenuse. That's 3 over 5. You can figure out what your missing side is. This is a Pythagorean triple, so this is a 3, 4, 5 triangle. Once you figure that out, you say, okay, well, what is on the other side of that equation? So the cosine, how would I rewrite it? The cosine of something, of some theta, which we just figured out over here, is going to be what, right? So the cosine of theta is going to be what? So I go back to my triangle and I confirm. So the cosine of theta is going to be adjacent over hypotenuse, which is 4 over 5. Okay, in question number 4, again, we're looking at drawing a right triangle. So very beginning, we're going to start off. Arc cosine is going to be in 1 and 2. And if I rewrite, I have the cosine of some angle is going to equal negative 5 over 13. So if cosine is my x, I know that cosine is negative in quadrant number 2. So then what I would do is I would say, okay, I'm going to draw my triangle here. So here's my triangle looks like. Here's my theta. Okay, it's going to be in quadrant number 2. So I know that cosine of theta, my cosine is going to be -5 over 13, which would make sense because on the bottom, which is on that negative x-axis, that's going to be the -5. So again, this is a Pythagorean triple. So I have a 5, 12, and 13. I'm in quadrant 2, so the y is going to be positive. So again, I ask myself, so the sine of my theta is going to get me what? So the sine of theta is opposite, which is 12, over hypotenuse, which is 13. Okay, so I hope this video helped you be able to understand what inverse trig functions are in both graphs and application questions. Don't forget to like and subscribe for future notifications of other precalculus videos. Thanks for watching and have a great day.